First, we're going to be taking notes, so please get some notebook paper and just write the following. The title of this paper will be Systems of Linear Equations. The date is October the 8th. And we're going to talk about how systems of equations are divided and how we can classify them depending on whether they have a solution or not. So when we refer to the word systems, we're talking about two or more equations. So from there, we're going to classify them into two. One will be inconsistent, and the other one will be consistent. An inconsistent system is something that has no solution. A consistent system is going to have one solution or an infinite amount of solutions. So we're going to say infinitely many solutions. Now, graphically, inconsistent systems, they are lines that do not intersect. And so those lines are going to be parallel lines. So remember, inconsistent systems have no solution, and the reason for that is that graphically they are parallel lines, therefore they will not intersect. Now we have consistent systems, they have one solution or infinitely many solutions. And so the ones that have one solution, it will be lines that intersect at one point. Now let's talk about the ones with infinitely many solutions. And so those systems, when I say they have infinitely many solutions, those solutions need to come from the points that belong to the line, okay? And the reason we have so many of those is because we're talking about lines that overlap. And so if there are two lines that are overlapping, we could say that maybe they are the same line, and it could just be written in a different form. An example of that could be, let's see, 2x plus 4y is equal to 6. And then the other line could be something like 6x plus 12y is equal to 18. So if you notice, one of the equations, well, the second equation is just times the first one times 3. So if I was to graph it, you guys will see that will be the same line. So I'm going to pause the video for a second, and now we're going to move on to something else. So that's it for notes, okay? What we're going to do next, we're going to keep taking notes for like a few more minutes, and we're going to go over 3 types to solve systems of linear equations. So one type is going to be, well, let's write that as our subtitle. So this will be, let's call it methods of solving systems. And so one of those methods is the one that you guys did on last class on Tuesday. So that method, it is graphing. And so to solve a system by graphing, you could use several things. You could either plot points by substituting x values into the equation. To find y values. So that is one way. Another way will be to use the y-intercept and the slope, which is the rise over run, to graph a line. Now this method, it is convenient if your equation or your function, it is written in slope-intercept form. Okay, so that is one of the methods. We're going to talk about two other methods today. And so the next one is going to be substitution. And well, let's do an example here. Okay, so the example is going to be the following. X minus 9y is equal to 51. That will be my first equation. So I'm going to label them as equation number 1, and the other one will be equation number 2. My second equation will be 3x plus y, and that is equal to 13. So the steps that I'm going to list, we're going to be solving the system as well. So the first step is going to be to, let's say, choose a variable with a coefficient of 1. If you were to not have a variable with a coefficient of 1, you could still solve it. You just will have to do an extra step at the end and divide by the coefficient. So the reason I say so, choose a variable with a coefficient of 1 is because while you're solving for it, it will be pretty easy. So in this case, we have 2, and you could see we have an x, right? 1x or 1y. So Leslie, Bañuelos, which one do you want to solve for? X or y? X on the first equation or y on the second equation? X, okay. So we're going to solve for it. So we're going to solve for x in equation number 1. So when I say solve for it, that means that we're going to leave it by itself, to isolate it. So in this case, we will have x minus 9y is equal to 51. So if I want to solve for x, it will be 51. We have a negative 9y, so we know it's subtracting to the x. So if we move that across, that will be doing the inverse operation, which is addition. And so that will turn into plus 9y. Now we are done. And I'm going to refer to this as the expression found. Okay, so that will be our first step. Now, next step, we're going to substitute the expression found into equation number 2. Let's say into the other equation, which in our case will be number 2. Let's add here and solve for that variable. For the step A, so remember I added that statement to step A. So choose a variable with a coefficient of 1 and solve for that variable, which we did here, right? Okay, now next step was substitute the expression found, what I have enclosed here in the red rectangle, and into the other equation. So that's what we're going to do here. So now equation number 2, it says 3x plus y is equal to 13. And so what we're going to do here is that this x here is going to be substituted with the expression found. And that's why we refer to this method as the method of substitution, or substitution method. So then we will have something like 3 times the expression found is 51 plus 9y. And then what am I forgetting before the equal sign?
Y.
So plus y right here. And then is equal to 13.
So you lengthen 51 and minus and add the y's together.
Well, before we do that, we have to distribute the 3.
Oh.
Because the 3 is multiplying everything inside the parentheses. So, to the other equation, let's add to that, simplify as needed. So let's go ahead and do that. So it will be 3 times 51, that will be 153. And then 3 times 9y, that will be equal to 27y. And then let's not forget that we still have a plus y and a 13. And let's add to our step and combine like terms. Okay, so here the like terms will be 27y plus y. We know that is equal to 28. And now once we have simplified that, we're going to solve for that variable. So remember when I say we're going to solve for that variable, I mean we're going to leave it by itself, right? So we have here, I'm going to leave my y, 28 y's on the left side. On the right side, I have 13 already. This 153, what is that doing to the y's? Adding, right? We don't see a sign in front of it, but we know there is an implied positive sign. So that is adding. So if we move that across, it's going to be subtracting, because that will be the inverse operation. So minus 153. So now we have 28y, 153. Remember, when you have two numbers with opposite signs, you get the difference between them, and we keep the sign of the number with the biggest absolute value, which in this case will be the negative, correct? So then 153 minus 13, that is 140, negative 140, thank you. And now, what is the 28 doing to the y?
Divide.
But it's multiplied, so we divide. So negative 140 divided by 28. And so we know that is going to be negative.
Negative 5.
Negative 5?
Yeah.
Thank you. Negative 5.
I made sense with 8 and 40. Thanks.
Cool. All right, so now from there, let's move on to the next step. So we have A, B, C, D, E. And so that will be, let's say, once you have found a numerical value for one variable, you're going to substitute it into the expression found. And remember the one that I enclosed in that red rectangle into this one here. And so we already know that, well, the expression found is 51 plus 9y. We already know the numerical value for y is negative 5. And so if we do that, that will give us the x value. So that would be x is equal to 51. 9 times negative 5 is negative 45. And so x is equal to 6.
So 6, negative 5 is the intersection point?
Correct. So, very good. So if we translate that to a graphical representation, the point positive 6, comma, negative 5 is going to be the intersection point. So based on that, the classification of systems, would you guys say that system is consistent or inconsistent?
Consistent.
Consistent, very good. One thing that I forgot to add to that, there's one more word that we need to add. Well, two more words. When a system has one solution, we call it independent. And when a system has an infinitely many solutions, how do you guys think we will call it?
Dependent?
Yes. Dependent. All right. So now, how about we take a break, because I've been talking for a long, long time. Yes? So I'm going to pause the video, and we'll go outside, take like a 5-minute break, and then we'll continue. Next method we're going to cover is elimination, and also this method is known with another name. Do you guys know what name is that?
No.
Combination.
Besides that? Addition. So elimination, some books refer to it as elimination, others as addition, others mention both. So for this method, we're going to solve an example. Let me pick one. Let's see. So we're going to choose. I'm going to choose a method. So for my first equation, we're going to have 6x minus 7y, and that is equal to 47. For the next one, my second equation, it will be 2x plus 5y, and that is equal to negative 21. Okay, so the steps for this method will be as follows. So first, we want to select a variable that we want to eliminate.
I'm trying to remember this now.
Yeah, this is from Algebra 1.
Yeah.
I can't remember how to spell eliminate.
Solve for that.
Okay, so Julian, which one would you like to eliminate? X or Y?
I go with Y.
You go with Y. All right. So if we had coefficients that were opposites, for example, don't write this down, but if you had something like 6x minus 7y is equal to 47, and then we had something like 2x plus 7y is equal to negative 21, then it will be pretty easy to eliminate. So what you do is you add equation number 1 to equation number 2, and when you do that, you know that these two are opposites, so they will go up to 0, right? So we may say they cancel or they get eliminated. Now, that is not the case with our system. We have a positive 5y and a negative 7y. So what we're going to have to do, let's say, if the coefficients are not opposites, remember the term opposites, that refers to the same coefficient, same variable, but opposite sign. So if the coefficients are not opposites, then you need to multiply one or both equations to eliminate the variable. Now, if Julian had chosen to eliminate x, we could have just multiplied the second equation by negative 3, right? Because that negative 3 times 2x would have given us negative 6x. But he chose y, so we're going to do what he said. So because of that, the first equation is going to be multiplied. Now, you can see that 5 and 7 are not divisible by each other, right? And they don't have a common factor. So what we're going to have to do, but they do have opposite signs. So that's a plus. So what I'm going to do is multiply the first equation by 5. And the second equation, which is 2x plus 5y, is equal to negative 21. we're going to multiply that by, not by negative, but by 7, simply by 7. Okay. Now, when we do that, we must distribute that number to every single term, and including the constant term. So, from the first equation, that will turn into
30x minus 35y
okay.
is equal to 100 and
So that will be 200 plus 35, 235. 235. All right. Now the second one, we're multiplying by 7. So again, we must distribute that 7 to every single term. So
14x.
okay, so 14x
35y is equal to negative 1.7.
negative 147. Okay, so now the next step, and we're going to call that step part C, that will be to add the two equations. And so that's why we can refer to this method as addition, because you add two equations with the purpose of eliminating one of the variables. So we're going to eliminate the ones with opposite coefficients. That will be the 35y and the positive 35y and negative 35y. Now we're going to add 30x plus 14x. That will be 44x. And here we're going to subtract 235 minus 147.
Eighty-eight.
88?
Mm-hmm.
Okay, thank you guys.
And that only equals to.
Okay. Now, this is pretty easy to solve for x, right?
X.
So the 44 is multiplying to the x, so how can we solve for x? Divide by 44, because that would be the inverse operation. And so because of that, so we get that x is equal to 2. Okay.
So now we have to substitute into a
Correct. So, substitute the numerical value that was found into one equation to find the other numerical value. All right. Now, here you have the choice to choose equation number 1, equation number 2, or even one of the the ones that resulted after multiply. Yes. You wanted to choose one?
Yeah.
Okay, which one do you want?
2.
Okay, 2. So let's choose equation number 2. So that will be 2x plus 5y is equal to negative 21. So now what I'm going to do is replace this x with a 2. And so that will be 2 times 2 plus 5y is equal to negative 21. So 2 times 2 is 4, plus 5y is equal to negative 21. Now, after that, we're going to solve for y. So we will have 5y left on the left side, and then we have negative 21. This positive 4 is adding to the y's. So we move it across, and we'll do the inverse operation, which is subtraction, so minus 4. And then we have 5y is equal to negative 25. From here, we know 5 is multiplying to the y, so bless you. So we need to divide by 5. So that will be negative 25 divided by 5. And so we get that y is equal to negative 5. So now, graphically, if we were to graph them, the point of intersection will be 2, negative 5. And we call that point the solution to the system. So is the system consistent or inconsistent? Consistent. Is it dependent or independent? Independent, because we only have one solution, right? Okay, so that's it of me talking, so I'm going to pause this video.
And now we gotta do all 10 of these questions on the back. But we just did.
It's up to the top. Oh, okay. Thank you. Thank you.